What's up, guys? Today I wanted to build a live chat app, full stack, using React, Node, and WebSockets. So let's dive right into it and build a rock solid plan so we know exactly what to do before we actually start coding. As mentioned, our front end is going to be in React. So this is our page over here, and I'm going to draw a circle for our server that's running Node. Within our front end, we're going to want four major components. And our page is going to be divided a little bit like this. Right here, we're going to have our topics. Let's say we have a bunch of different channels like general, and then maybe channels for different programming languages if we want to make this a programming discussion chat board. And then over here is where our messages are going to appear. So it'll be like a person's name and then message and a bunch of those. And that'll be all the messages within the active channel. I think we also want a title that's telling us what the active channel is, as well as just what page we're on. You always need some kind of a label on your page. Now down here is going to be where you type your chats, and you're going to send them with this button to whatever the active channel is. Okay, I'm going to actually remove these arrows to make it a little cleaner now that we know what everything is. We have our four sections. So to both send and receive data, we need to communicate with the server. And we're going to do that over something called a Websocket Tcp Connection. TCP is the same thing that standard HTTP requests are using, but in WebSockets, it's a continuous open connection that you can send a stream of data over and also be receiving data. So, like I said, you can send from the client to the WebSocket server, and then you can also receive more data through what's called a broadcast. Now, this sounds a little bit complicated, but there's a library called Socket.io that runs in conjunction with Express to make us able to do this in about 20 lines of code only, which is pretty sweet. All right, one more thing I want to draw is within our front end, we're going to want a store to actually keep our chats inside, and we're going to use React hooks and context to accomplish this. When we receive broadcasted chats, we want them to run through our reducer and then render on our page. To keep our state separate from our actual components, we'll use the React context store. That's enough planning. Let's actually start to build this by opening the documentation for all the stuff we're going to need in advance as we install our dependencies. So I've just popped open docs for Socket.io, which we're going to use for our server, as well as Material UI, which we're going to use for styled components on the front end. If you've never used styled components before, it's super easy to get up and running. Let's create a React app called Chats. We'll change into Chats directory. In our directory, we want to install our dependencies we know we're going to need. With yarn add, you can also use npm install. Now let's start our React server here. And first thing I'm going to do is clear out the code that we have. Delete all that and all of this too. Clean slate. Looking over at our plan, we divided the front end into 4 different sections. Now, instead of making 4 different components, I'm actually going to pretty much write everything in one component. You can refactor it after you do this, but if I have a well-contained set of components, I usually do it in one file to prevent the time lost from switching around so much. It's always better to do smaller components, but in terms of mental overhead, this can make your workflow a lot faster if you remember to break them up after a certain interval of time working on them. In my case, I'm going to make a file called dashboard.js and import React in this. and then import dashboard into my app component. Now I'm gonna put dashboard in just like this. Of course, I need a function as well here that returns some JSX. Now that I'm up and running with some kind of an app here, let's dive directly into our Material UI docs. The best way to use these is just to find a component that you want to use. Here's a list of all the components over here. I found one called Paper, which just gives you a little bit of a three-dimensional box that you can use on your page. And then once you find the component you use, you just click into the code snippet button, and then you copy both the import, like this, and also the component as it appears here. We also want typography, which we'll use more. Well, we can actually use that for basically all our type to have some nicely formatted text. And one more thing you might have noticed is this make styles. And we also want to use this because this is the common pattern. It's called CSS in JS. I get these styles into this class's variable, and then I can inject them with a class name. And what make styles does for me under the hood is then render the CSS when the page renders. Save all that. Still missing Material UI core. So maybe I didn't install it right. All right, nice. Our sheet of paper is taking up the whole screen. As we mentioned, we can type CSS here. So if we just use a margin of 50 pixels, we'll get some separation from the edges. Nice. Okay, so this will be the foundation of our whole chat window. Looking back over here, we want to divide this into 4 sections. Let's keep this title as the title of our chat app. And then below that, this title can eventually be our topic. But for now, it's just a placeholder. Let's make this one a H3, and this one a H5. H3 is a little too big. Below this, we're going to start dividing up our real estate. And I want to do this with a couple of flex boxes. One for the top section, one for the bottom. Add class names of classes.flex, which we define up here in our make styles. We're also going to definitely want classes for all our 4 elements that we talked about. So let's do topics window. Chat window. Chat box. Button. Let's think about how we want to divide up our widths. Left side, maybe 30%, 60 here. And then this one will be like 80, 20. Topics window with 30. $70. do 85, 15, and of course we're going to need some height too. So these are going to be equivalent, let's say just 300. And we'll just leave those for now as nothing. Okay, so let's create these subcomponents. Topics window. Already getting a lot of markup on our page here. Chat box. Well, I'm going to leave these out for now because these are going to be Material UI components as well, not just containers. All right, so our height is already working as we want it to. It's good news. Topics window, maybe we'll also give this a right border, just to see where that separator is. Okay, we'll leave it like that for now. Thinking about what we want to go in our topics window, I'm thinking we use a Material UI list, which gives us a couple nice little styles on just a standard list that we would map over. We need 3 different components from here. We don't need the icon one though. Then let's make it like a list like this. List items. Just gonna copy. It's all about the copy and the paste. Take this out, keep this in. Then we'll map over some data here. Right now it's just an empty array. Topic like that. Return this. And that'll return just an empty, well, it'll return nothing. Let's put it that way. Until we actually have some data. Okay. Let's just put one topic in there to see if it worked. Nice. So this is what I'm talking about. When I hover over, I get automatic styles for free with using Material UI, and you can see when I click, it looks pretty sweet. And I didn't have to write any CSS to do that, which is generally something you want to avoid because your CSS files can get real big. Okay, chat window, we're going to do something similar, but we don't need it to look like the actual list. This can just be mapping over elements. So I copied it to just keep the map structure that we have. And I actually want to map objects. This will be from user, and then the message will be hello. Get the chat content here. And instead of a list item, I just want a div. Gonna make it another flex class because I have something in mind for this. I want to get a chip component from Material UI that looks kind of like this, where I can actually even have an avatar if I want one. Import it, get the basic chip like this and throw it in here. Just like that. Label will be chat from. Need a key on this still. Chat. That might not be unique, so let's actually make this index. And on the right side, we actually want just the message. Let's keep it in a div in case we want to give it style later. Rather, let's do typography. Typography. Variant P. Put message here. Chat.message. Okay, that was a lot of code, so you always get a little bit nervous before checking that, but not to worry, we don't have to be concerned about that error. We just forgot one thing. And nice, so we have this here already. Let's add one thing to our flex class to make it vertically centered. The align items property will take care of that for us. Need S here. Okay, so now that's vertically centered, and I think we also want to provide some padding on our chat window here. Okay, it's already looking a little better. Let's just leave it like that for now. It's not perfect yet, but we can adjust it again later. So we have 2 out of 4 down. Not sure how we're doing on time. I think we're going relatively fast. And those are the 2 more difficult components. So now we just have to build our button, which is, you might have guessed, just a material UI component here. See how fast we can do that one. Let's get this primary button. Just import button. Take it from here. And make the send. See how this is coming up. Okay, nice. And on the left, we're going to want a text input. Text field. I think just get the most basic one here. Text field. And all right. Okay, we'll hold on to this handle change, even though we don't have this defined yet. Let's take this out. Let's make this whatever is matching up here. Chat box. Label will be send a chat. Don't need an ID because we only have one. And value will be handled later when we define this, which will be actually in just a minute. Okay, wow. So that pretty much worked out of the box. We don't even really need a additional styling here. And since this is not a controlled component, we'll see that we can actually type. But that's not exactly what we want, because we want to have this in some local state. So last thing we want to do is, I think, just make sure we're capturing this in our state. by uncommenting this. We're just doing this in advance, text value, and then change text value. Let's do some local state with the state hook. What do we make it? Text value, change text value. Default it to blank. If you're not familiar with hooks, I have another video on hooks, but basically what's happening here is we're initializing a state to nothing, and then we are passing this empty string into this value, text value, which is our initial state, and then when we want to update it, we just have to call this function. So useState is returning a tuple, first our current value, and then second our update function. This is only not working because we need a wrapper around this. And this will be an event, and then change text value e.target.value. Okay. Still works. Great. All right. We are pretty much done with our front end layout. Didn't take too long, doesn't look too bad. And like I said before, you can refactor it out to be multiple components, particularly the parts that we're mapping. But this is actually already components from Material UI, so don't feel like that is actually necessary to do. Okay, dashboard is done. Let's create our store. This is going to be a wrapper, or rather a context provider that simply holds all our current chats in the state. And if we think about this before writing it, we're going to definitely want a reducer to have greater control over what's being returned from the server and map it to the shape we expect. We also want just an initial state to make sure everything's working correctly in our layout. So let's create both of those things now. Absolute first thing we want to do though is do a react.create context, which just initializes a context object. Now I'm going to export default a functional component called store, which will return a context provider with a value that is going to be passed in. Now, of course, we also need props.children, so we define this as a higher order component that wraps around the rest of our application and renders the rest as normal, but gives it this additional functionality with the store wrapper. All right, in here we're gonna create our reducer with react.useReducer, and this takes two arguments: our reducer function and our initial state. Let's rename this reducer hook and then reducer here. Okay. Reducer is a function that takes two arguments, state and action. Action is an object we manually pass in. Now the common convention is a switch on action.type. And we will set these action types, but I think send message, rather receive message, makes the most sense. Okay, this is probably, well, let's just make our default case first. Now this is probably going to be the most complicated part of this whole demo. And it's how do we retain our existing state while mapping over a chat that we receive and re-rendering the page. So the chat will come in with a topic on the object, like this. So what we already defined in our component was we're definitely going to have these properties called from, which is a username, message, which is a actual message, but to know what channel it goes in, or rather what topic it goes in, we're also going to need a topic key from our server. And let's just say this is general. So this is what we can expect to come in through this reducer action payload. And as I mentioned, we have to retain all our current messages while adding the new one in to the end of a topic's array. So if this is one message, I'm thinking about our entire state looking like this. It'll be an object with topics as keys, topic 1, topic 2. Within that topic, you're going to have an array of messages that are messages like this. So these are messages. And then the same here. Oh, I messed that up. Like this. These are each their own object. So you get it. Same thing as up here. When we think about, maintaining these, but implicitly the reducer also has to be immutable and make a copy every time, the natural way to do it is to use the spread operator. This first spread is bringing forward our entire old state, and then what we're going to want to do is overwrite a single key which is whatever topic the message is in. So this destructuring here allows us to pull the topic of the message off. In this case, it would be general, and use it as a key in an object. So we're overriding the entire general key on this state spread, and we're defining it as this new object. Within this, let's say this is general and we have 3 messages in. We don't want to lose these messages. We actually just want to add a new one to the end, right? So we have to again use a spread here on state action payload topic to bring forward the old messages. Okay, now we are, and I typed this wrong, this is an array. So we've spread in our old messages, and the final thing we need to do is type in our, or rather get our new message in here, which is going to look a little something like this. And then message will be action payload message. Now we can slightly refactor this to use some destructuring, get everything a little more clean. From message topic, pull that off of the action.payload object. Now we could simplify it like this, and simplify this like this. This is exactly the same as what I just had typed. Okay, hope that made sense. This is our reducer. So we're passing in our reducer. And let's make our initial state equal to essentially what we have here. Need a comma. Need a couple actual messages here. Okay. And finally we pass in reducer hook here. Okay. Moving on, we gotta wrap our entire app with this store to get access to our current state. And dashboard here is children, so that'll just render the same way it did before. But now there's one key difference. We can actually use the context, assuming we also export this. We can use the context to pull out of that store here. Let's do a comment, context store. Now all we have to do is get our store, which is a list of all chats, as well as our dispatch, which allows us to trigger a reducer event. Actually, no, let's just leave this out for now. Okay, now let's log this out and see what all chats is. We got our object here, and nice, our chats are here. So we've got some stubs in here, but if we actually want to map these chats and topics out, we have to do a couple changes. The first one being getting an actual list of our topics from our state, and I'll deal with this error next. I think it's just we just need to look at the typography docs and see what we're doing wrong. Variant body one, let's just use that. Not sure what it's gonna look like, but typography. Let's do this too. Gutter bottom. Okay, cool. Okay, we're logging out all chats. I want to get a list of my topics by just doing object keys. On all chats, which will just pull off the keys off this state object general topic 2. And then I could just map my topics like that, and that'll work. Now I can select between them, but instead of my placeholder, I want this to render my active topic, which is going to be held in my local state. Just going to comment this here because we're also using text value in local state, and I'm just going to use another state hook to make the abstraction clean. Let's default this one to our first topic that we get in our object, just so we have one that's always active. Topics 0. Set a topic placeholder, let's use active topic. Okay, nice. Now when we click on our topic list, we need an on click that will actually change our topic to whatever the value is in here. So this will be an E. And this will be change active topic. And since this is just text and not a text input, I believe we're going to need e.target.innerText. Let's see if that works. Sweet. So we see our topic 2 generals changing here. Next thing is to actually render the chats. And since we want to render them one topic at a time, we just access our all chats object with active topic. We can see this is general and this is topic 2. The chats are changing. Sweet. Okay, since our front end is pretty much done except for our listeners, we can start building our back end. What do I mean by listeners? Okay, I have to go a little bit more into sockets here. First, you need a connection from the client. So client connection is step 1. Step 2 is you have a listener on the server that will listen for not only actual connections, but it'll listen for what's known as emit events from the client. So when the server is listening, we can send emit events from client. Since the server is listening for this event, it will receive that event with a key and with some JSON data that it can then send out to one or more other clients who are listening, and that's known as a broadcast. When this broadcast happens, all the other clients receive this message, including the one who sent it, but this is all defined in your server logic. And there's no 5, it's just client receives message. Let's make a new actual directory over here called server. Within server, index.js. Let's pop up in the socket.io docs. We already installed Express, but let's copy the boilerplate Express server. And let's make ours actually listen on 3001 instead of 3000. That's where our other app is running. And we open a new terminal window. And then just run node on server index.js. We're listening on 3000. Okay, so now, like we mentioned in our diagram, we need to create a server listener. IO on connection, log a user connected. I'll save that and then restart. Over in our client, and I'm going to do all this logic in store because it's more related to the data and not how the data is rendered. I will import the socket.io client library. Socket.io client. Okay, to initialize this socket, I'm going to declare a variable called socket outside of my actual function, functional component rather, because I don't want this to re-render every time my store reloads. Now, inside my functional component, I'm going to check for a socket. If there's no socket started, then I'm going to create one with the IO function that I just imported and set it manually to the port 3001, which is what I defined in my server file, 3001 here. So this will be my client connection that will basically connect when my client starts. And the last thing I need to do is import the socket server library in my server. Start that up and keep an eye right here. See if we get our log when we refresh. Boom. A user connected. Okay, we're already connected, so we've got steps 1 and 2 down. How do we emit from our client? Well, we just keep scrolling down on this page. Emitting events is as easy as doing socket.emit. Now, the challenge with that is we want to emit from our dashboard component, but we have our socket initialized in store. So instead of just passing our reducer hook in, why don't we do it like this? Let's just bring our chats object here. Let's pass this in as part of a larger object. Now, when we use our context, we want to pull that off. So pull all chats off like this instead of the way we did before, and see if that's still working. Okay, nice. So this is just passing in an object with key, all chats, value, the value of our current state coming from our reducer. This gives us the ability to pass in more stuff. So we can pass in our actual action that's going to emit to our reducer. Let's define that action here up here in a function called sendChatAction. Right here we'll put in our dispatch, which we pass our action into. We'll put in our socket, which we can emit on, and that's pretty much all we need. We don't need to return anything from that. Okay, socket emit. This could be our channel key, just chat message, and the value can be another argument that we pass in. Okay, and I actually lied. We don't need dispatch at all. We'll need dispatch when we are creating our client listener. Okay, so sending chat message, let's just send a default message. Or no, let's do the whole thing. Value. Pass in send chat action here. We'll pull it off here. And then when we click our button, let's create a little more space. On click, we will just do our send chat action, passing in our text value. When we send our chat, I think we also want to clear our text value after we send our message, so we have a clean slate. Said that a little bit weird, but okay. Also clear text value. Change text value to empty string. Okay, send chat action. Send chat action. That was a lot of code. Let's see if it works, but last thing we want to do is log if we get an event on our server. So socket on chat message, log the message. Okay. Running the server. See if we connect. User connected. Okay. Moment of truth. Oh. Socket emit is not a function. Okay. We just got to pass in our socket. No worries. And how do we do that? Oh, okay. We can do this a few different ways. We can make this a double function where we create a closure with socket, or we could just move our function in our store. I don't know if that's best practice though. All right. Not using that right now. So you know what? Let's just do it. Let's do it like this. Message here. Nice, 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 nice. All right, so if you don't understand how that worked, we define socket above this function. There's a closure in this function that captures the value of socket in the context of this function, even if it changes. So socket is changing down here before we're ever calling this function when the socket is created. And we're emitting in the dashboard component, but the socket variable was captured all the way up here when the function was defined. So just to say that in a different way, functions that are not arguments are captured from the context of the function definition, while functions that are arguments are not captured until the call when they're actually invoked. And you can capture variables in your functions either way. All right. So there's one thing I still see that's a little bit coming up short here, and that is our message is just a string, but the value we're expecting is more like this. We need from, we need message, and we also need a topic key. And that's the fault of our client. We want to capture more data when we're sending this message. So message is text value. From is a user, but we don't have a user in our store or our context. So let's actually just create one manually. I'm going to make user my name, but since multiple clients are going to be connecting, let's do a math random of 100 and then round it. So we have a kind of a random number attached to anyone who's connecting. Then we can also pass this into our state, our application state that is, and we can pull that off here as well. When we send the message, we can now say from is user, whoever the user is in the client. And then topic is going to be whatever the active topic is, because we're just capturing that from our local state. Okay, now when I send, message is object, which is a good sign. If I restart that, it's the same. And let's just stringify this. Stringify message. Okay, that's exactly what we want. Nice. Okay. So steps 1, 2, and 3 are down. Step 4, broadcast from server. Well, we just keep scrolling down in these docs, and we can see socket.broadcast or socket.emit, which will also send to the sender, which is probably what we want to not get duplication. We could just wait until there's a response from the server before rendering the chat on the page. So let's just throw this in here. We're emitting on the chat message channel, right? We're sending out the same message that came in. And what we now need is a listener on our client. So we're waiting for the broadcast. Socket on chat message, boom, just like that. Again, chat messages are key, and we're receiving the message, and we just want to console log the message. Message like that. Restart server. Refresh. Okay. Oh, nice. Okay. Now, steps 1 through 4 down. No, steps 1 through 5 down. All we have to do is add this to our state, which means running our reducer, which means calling our dispatch, and we can do that by just moving this up this is our callback. Dispatch. Payload is message. And then type is whatever we defined in our reducer. Receive message. Okay, moment of truth. Moment of truth here. Guys, it worked. Just like that. Okay. Now let's see if we connect with a second client. This is our server. Sorry about that. If we will receive the chat. Like magic. 2 windows open. 2 functional randomized users. 66. 66. And this one is one behind because we're not loading the messages from anywhere. And that's the thing you have to keep in mind about sockets too, is they're not saved on a database. They attempt to send everything out. If the users miss them, then they're gone. They only do it once. They're not saved. So it's something you have to keep in mind if you're designing a chat app and you want to load chats up. You have to do some duplication where you're saving to a database and then perhaps loading from a database and weaving in the WebSocket chats. Excuse me. Okay, but this is pretty much it. If there's anything we can still delete, it's actually this. We could take that out. And we could probably do some additional refactoring, as mentioned, around the components where they are living. And because we have a lot in this component, and we can factor some of this out. But in general, this is a really good jumping off point if you want to build your own chat app. And I think we did it efficiently, so I'm proud of that. Let me know if you guys have any questions about this. If you like these long form kind of videos, that was actually pretty tiring, I would say, but I'm happy to keep doing them if you find them valuable. If not, I'll go back to the shorter, bite-sized videos. But anyway, hope you guys have a great week. I'll catch you guys soon.